So these lecture notes are going to pretty much cover what you guys covered in about 2 or 3 weeks in Algebra 1. So this is going to be pretty much a review with a little bit of additions because of the material that we've learned in Algebra 2 so far. And so we're going to treat this as Algebra 2. So we're going to go ahead and solve some basic quadratics. We're going to use some basic methods. Part A, we could do this a couple of ways. So the typical way we would have learned this in Algebra 1 is to identify this as a difference of squares. So in other words, you would identify this as x squared minus 2 squared. And what would happen is you could just split these up into 2. And your teacher would have told you one is a plus, one is a minus. And then each of these would have gotten an x. And then each of them would have gotten a 2. And then you would separate these and solve, like we've talked about previously. And so these would be the two roots or the two solutions for this quadratic. Remember, we've said in the past that quadratics will have up to 2 answers, and so we found these 2 answers for part A. However, because we live in a more sophisticated age, we're going to go ahead and do this a different way to show you what's going on. What if I move this 4 to the other side? I get x squared equals 4. Now, conceptually, we could ask you the question, well, what number, if I square it, would give me a 4? And you would say, oh, 2. 2 squared is 4. Well, what about negative 2? Negative 2 times negative 2 is a positive 4. So the way we would do this algebraically is I would square root both sides. And when I square root, I pick up a plus or a minus. And the square root of 4 is 2. So you might see some places that show the answer like this. But keep in mind that plus or minus 2, we say it as plus or minus 2, means it's a plus 2 or a minus 2. So either way, we got the same 2 answers as before. I'm not saying do it both ways. I'm just letting you know there's a couple of ways to do part A. So you see with part B, we run into some problems because if we try to do it like a difference of squares, it doesn't work out. There is no perfect square root of 8. There is a perfect square root of 4, 9, 16, 25, etc. But 8 is not a perfect square. So we find ourselves actually having to use the last technique that I showed you for part A, where we move this number over to the other side, and then we can square root both sides. And I pick up a plus or minus with that. However, this is not done. If you will recall when we did complex numbers doing a factor tree, right? 2 and 4, and I circle the prime numbers, and then 2 and 2, and I circle these prime numbers. And 8, or I should say square root of 8, can be expressed as 2 times 2 times 2. And when we square root, we're looking for pairs that come out. So here's a pair that comes out, and it comes out as a 2. So I can say that this is actually plus or minus 2 radical 2. Or in other words, you could say x is equal to positive 2 radical 2. Or it's equal to negative 2 radical 2. So those are our 2 solutions for this quadratic. You may not have done something like part B in your Algebra 1 class. Maybe you did, maybe you didn't. We're doing it now. Now, part C, you might think, okay, well, is there a square root of 2? No, but furthermore, there's no minus. So a difference of squares means that both of these have a square root, and there's a minus in between because difference implies subtraction. So we can't use a difference of squares here at all for both of those reasons. If we subtract 2 from both sides, we get x squared equals negative 2. And we're going to go ahead and square root both sides. And we get 2 answers. A plus or minus negative radical 2. However, we could write this as a negative 1 times 2, which we can then split up as a square root of negative 1 times square root of 2. And whether you remember doing imaginary numbers or not, complex numbers or not, you're new to the class or you just totally didn't do anything last semester, it's all good. I'm here to tell you that square root of -1, if you put in a calculator, it gives you error or a domain error or something weird, okay? I'm here to tell you that if you see square root of -1, you can replace that with an I. This is an I, not a 2. This I represents an imaginary unit. I would encourage you to watch the videos that I have on imaginary units if you want to know why we use I. If you don't care, well, great. All I'm telling you to do is, if you see a square root of a -1, you replace it with an I. So, in this case, for part C, we have two answers, right? We have either a positive I radical 2, or we have a negative I radical 2. And, you know, it's positive, so we don't even worry with that. So, if you're looking at some of the quizzes or worksheets or assignments or textbooks you're looking at, these would be our two solutions for part C. You might want to take some time to maybe pause and digest the use of the imaginary unit. You might want to retry part C on your own. See if you get the same results as I did. The grouping method is pretty unique. You're only going to really see this if you have like 4 terms like we do here. And again, this is quadratic. All of these problems are quadratic because the highest power is the power of 2. But what grouping has is it's exactly that. It has a group thing. So let's go ahead and cut this in half. And let's actually ignore the right side right now. And what is the greatest common factor that you can find in both of these? Well, it's going to be an x. And if you're not sure why, may I propose we break it down like we did in pre-algebra. X squared is x times x. And then 3x is 3 times x. So for those of you struggling a bit with factoring, we broke it down. And the question now becomes, what do both of these things have in common? They both have an x in common. So if I pull out that x, the question is what's left over? We have an x left over and a plus 3 left over. Now let's ignore the left side and focus on the right side. What does the right side have in common? Again, if you want to break this down pre-algebra style, I'm cool with that. So that's 2 times x. And then the 6 is 2 times 3. So the question becomes, what do they have in common that I could pull out? Well, they have a positive 2 and a positive 2 right here. So if I pull out a positive 2, what's left over? I have an x plus 3. Now, how do I know if I did this right? Well, because whatever's in the parentheses are identical. So what we do is, you see these numbers on the outside, the x plus 2, that becomes a parenthesis. And then these duplicates, I count them only once. And don't forget this was equal to 0. And now we separate and solve. It being a quadratic, of course, we expect to get 2 answers at most. And so in this case, our 2 answers are -2 and -3. Now, you know, at any given time, you could take these answers that we're getting and plug them back into the original problem. And as long as you can follow order of operations correctly, you're going to get that the equation statement is true. So for example, if I were to plug in a -2 into all of these, right? For example, I'd put -2 parentheses squared, 3 -2, 2 -2, plus 6 equals 0. If I do all of this math right by following order of operations, it'll come out to be 0, and it'll be true. So for those of you that like to check your work, you know what to do. You could go back to A, B, C, D, E, F, all of these, and if you take both of the answers you got one at a time, and you plug them in with parentheses, and you use order of operations correctly, you're going to see that these are true. E should remind you of A. Okay, this is like in the next step, right? So it's already been moved over for us. So we can square root both sides. And I get x equals, what's the square root of 4? 2. But when we square root, it's going to be a plus or minus. Or in other words, the answer will be a positive 2 or a negative 2. So those are our two roots, or our two solutions, or our two zeros, right? Because if I were to plug in this negative 2 in for the x, well, what's negative 2 squared? That's negative 2 times negative 2, and that's a positive 4, and that's the same as the right-hand side. So that makes it a 0, or a root, or a solution. And for part F, we don't quite square root yet. It looks like you want to, but you can't. You have to make sure the x squared is by itself before we square root. So I need to divide by 8 first. And I get x squared equals 4. And surprise, surprise, this reverts back to a previous problem, right, part E. And so I'll leave it up to you to check that it's either plus or minus 2, right? This means that there's two answers. It could either be positive 2 or it could be negative 2. For your summary, even though parts A, B, and C all look very much alike, describe how each was solved differently and why.